So this is going to be a quick linear correlation and regression example. So in this example, police sometimes measure shoe prints at crime scenes so they can learn something about criminals. Listed below are shoe print lengths and heights of males from a sample of 6 males. So for example here, 29.9 centimeters is the shoe print length of one male, and his height was 172.4 centimeters. So in this case, because we're using the shoe prints to learn something about the criminals, in other words, to predict their heights, the shoe print length is going to be our explanatory variable, and the height is going to be the response variable. So remember, this is our independent variable. Sometimes we use x. And this will be, the height will be the dependent variable or the y variable. So there are some questions that we can ask about the data, pairs of data that we have here. The first question we might ask is, what does the scatter plot tell us? So we can construct the scatter plot, examine the scatter plot, and then ask, does there appear to be a relationship? Is that relationship linear? We might also want to calculate the linear correlation coefficient R, and what does it tell us? We can also use StatCrunch or other technology to find the regression line. And once we have the regression line, we can ask, what is the slope of the regression line and what does it tell us? Like, how do we interpret the slope? Finally, we can use the regression line in the case that there is a linear relationship to predict heights. Most of these quantities are difficult to calculate by hand, so I'm going to use StatCrunch to show you how to create the scatter plot, the linear, how to find the linear correlation coefficient, and the regression equation, and then we're going to use those quantities to answer these questions. In order to use StatCrunch to create the scatter plot, I can enter the shoe print lengths into the first column, and then I can enter the heights into the second column. If I happen to have that data in an Excel spreadsheet, I can just use the command data load from file on my computer. And in this case, I do happen to have the data in a spreadsheet. So we're going to have shoe height. And then I click on upload. Okay, and there are my shoe print lengths and my heights. So I don't have to enter them by hand if I have the spreadsheet. The next thing I'm going to do in order to generate the scatter plot and the linear correlation coefficient and the regression line is I'm going to go to regression, simple linear, and I'm going to choose the explanatory variable, which in this case will be the shoe print length, because that's going to be predicting the height. And then for y, I'm going to choose the response variable, which is height. And the only thing I need to do next is hit compute. And you can see in the readout here, the linear correlation coefficient is right here. Okay. And you can also see that the regression line is here. And if I click on the arrow, you can also see the scatter plot. So the first question I have is, if I look at the scatter plot, does it appear that there is a linear relationship between the shoe print length and height? And you can see that it really does appear that there is a linear relationship. And since I've established that there is a linear relationship, I can go back and now I can look at the linear correlation coefficient, and this tells me the strength of that linear relationship. 0.92 is very close to 1. So this tells me that there is a strong positive linear correlation. So before we leave, I'm going to just write down for myself the regression line, and I'm going to use that later. I'm going to interpret the slope, and I'm going to use the regression line later. But I'm going to round it to 2 decimal places. So let's come back and answer the questions since we've used StatCrunch. What did the scatter plot tell us? And we learned from the scatter plot that the sample data did exhibit a linear relationship. And the linear correlation coefficient was about 0.9259. And since the scatter plot did exhibit a linear relationship, this tells us that there is a strong positive linear relationship in the sample. Okay, and what is the regression equation? So again, using StatCrunch, we found y, which is the variable for the height, was about 36.77 plus 4.59, and these are rounded to 2 decimal places. And remember, x represented the shoe print length. So what is the slope of the regression line? That is the coefficient of the x variable, so the explanatory variable, and that was 4.59. And the interpretation is that for each increase of 1 centimeter in shoe print length, the height of the male increases by about 4.59 centimeters. So that's the interpretation of the slope of the regression line. So according to the regression line, what is the predicted height if the shoe length is 30 centimeters? So I'm just going to pop 30 centimeters into the regression equation. And multiplying these guys first and adding 36.77 gives me 174.47 centimeters. So this is the height, that is the predicted height given by the regression line for a male, a male having a shoe print length of 30 centimeters.